Hi, in this series we're looking at creating geometrical shapes using custom meshes in Unity. In the last episode we looked at adding UV mapping to our meshes, and in this episode we're going to extend our code so that we can view our changes in the editor window without having to hit play to see everything. Let's get started. Here I've got a simple scene using a regular polygon with the UV mapping script. I've got a hexagon with a plain red material and a pentagon with a checkerboard pattern. This looks fine when we're in play mode like this, but when we exit the scene, it's completely empty. We've got very little indication of where our objects are. One way of improving this would be to add an icon to the GameObject. You do this by selecting the cube icon by the name, and you can select different types and colours. One disadvantage with this method is if you zoom far away, then they disappear. You can change the thresholds in the settings, but this representation isn't really that helpful anyway. Instead, what would be ideal is to be able to create the objects now in edit mode, rather than waiting until we press play. As Unity likes to be helpful, there is an attribute we can add to our mono behaviour so this happens. It is ExecuteAlways. This means that the code will run both in the editor and during playtime. This is great. However, our code as written is going to have some issues now. In edit mode, the start method will run, and it'll add the mesh filter and the mesh renderer to our object. All well and good, until next time of course, when it tries to do it again. It finds they're already there. So we need to check if they already exist before adding them. Whilst we're here, we'll cache them to a variable with a bit more scope so we don't have to keep getting references to them if we want to update any properties of our polygon. So here we have 3 private references to our mesh objects, and in the new awake function, we now attempt to get the references to the components using getComponent method. If we fail to find one, the result will be null and we can proceed to add them. Now back in Unity, we can see the polygons in edit mode. This is great. However, when we change a parameter, such as the radius, this isn't reflected till we force it to call awake again, such as by entering and exiting play mode. Unity provides the OnValidate method, which is called whenever a parameter is changed in the inspector. As the name suggests, this is primarily used so that you can provide restrictions on parameters when they're changed, but we're going to hook into this to apply the changes to our pentagon. All the remaining code in the start method is used to create the polygons, so we can just call that. We do need to be a little careful here. The OnValidate method can be called before awake when you first load the scene. So we just check that the mesh has been assigned to stop getting an error in this edge case. We also need to add one line to the start method, mesh.clear. This means that when we update the parameters, we make sure we clear out the old mesh before recreating it. So now back in Unity, you can see that we're able to modify the parameters, such as the radius and the number of vertices, and it updates for us. One thing you may have noticed is that on some polygons, such as the square, the texture may not be quite in the orientation you expect, because we always start with a vertex at the top. So back in the code, we'll add an extra parameter to define the starting angle so we can rotate our polygon creation and thus the mapping to UV coordinates. I'm assuming most users will enter the angle in degrees, so the first thing we need to do in our start method is to convert this to radians so it works with our trigonometrical functions. Then all we need to do is add this as an offset to our I times angle parameter in each of the 4 trig functions. That's it. Back in Unity again, we can now modify this starting angle to make our checkerboard pattern on our square look a little better. It's a bit annoying that these parameters take arbitrary values, so I'll add some more attributes to them so they don't end up taking illegal values, such as a negative amount of sides. For our radius, we don't want to limit the upper bound, but it doesn't make sense to have a radius smaller than 0, so we can use the min attribute. For the number of vertices or sides, 3 is the smallest valid value, and you may want to limit this to something like 30, so we use the range parameter. This works for both integers and floats, as Unity uses the type of variable to give you a slider with the right increments. Finally, for starting angle, 0 through 360 is good, so another range attribute there. These all now work in the editor in the way you expect. As a final addition for this episode, it would be really nice if to create a polygon, we didn't have to create an empty object then add the script each time. What if we could use the right-click menu like for all the other primitives in Unity? To do this, we need to create a new folder called Editor, which holds the editor scripts. Then in there, we create a new script called Regular Polygon Editor. In here, you can do lots of fun things like adding custom buttons and fields to your objects that will display in the inspector so you can interact with them. We're only here for the creation menu though. First, we need to make sure we've included the Unity editor namespace, and we change our script from a mono behavior to an editor. We'll need to tell Unity what type of object this is an editor for. You can do that with the custom editor attribute. We'll create a function to replicate the workflow we would have followed. The first thing is to create an empty GameObject. We assign it the name Regular Polygon here. Then we use add component to add our script onto it. Simples. The final thing to do is to tell Unity that we want to assign this function to a menu. We do this with the menu item attribute. Here you give it the path in the menu you want it to appear under, each / representing another level down. You need to start it with GameObject if you want it to appear under the GameObject creation menu. Then we'll add it to a custom object submenu, an element called, surprise surprise, Regular Polygon. Now, on your right-click menu, this appears, and it's much easier to add the item to your project. As ever, the full code is linked in the description below, and I hope you found this information useful in some way. See you next time!